Lesson: Methods for reducing bias in AI. Reducing bias in artificial intelligence systems is a critical aspect of ensuring fairness and equity in their deployment and decision-making processes. As AI systems increasingly permeate various sectors, the potential for biased outcomes poses significant ethical and societal challenges. Addressing these challenges requires a multifaceted approach that includes understanding the sources of bias, implementing practical tools and frameworks, and applying step-by-step strategies to mitigate bias effectively. Bias in AI can originate from several sources, including biased data, algorithmic bias, and human biases that inadvertently influence AI models. Data bias is often a primary contributor, as AI systems learn patterns from the data they are trained on. If this data is biased, the AI system will likely replicate and even amplify these biases. For instance, a study by Buolamwini and Gebru demonstrated significant gender and racial bias in facial recognition systems, revealing higher error rates for darker-skinned individuals and women. This highlights the importance of using diverse and representative datasets in AI training to minimize bias. One actionable method for reducing data bias is through data augmentation and resampling techniques. Data augmentation involves creating synthetic variations of existing data to balance the representation of different groups. For example, in image recognition tasks, techniques such as rotation, flipping, and color adjustment can create a more balanced dataset. Resampling, on the other hand, involves oversampling underrepresented groups or undersampling overrepresented ones to achieve a more equitable distribution. These methods help ensure that AI models do not disproportionately favor any group, thereby promoting fairness. Algorithmic bias can also be addressed through the implementation of fairness-aware algorithms. These algorithms are designed to ensure that the decision-making process is equitable across different groups. One such approach is the use of adversarial debiasing, which involves training an AI model alongside an adversary whose task is to identify and penalize biased predictions. By iteratively refining the model to minimize bias, adversarial debiasing can effectively reduce algorithmic bias. Another technique is the use of fairness constraints during model training, which explicitly incorporates fairness metrics into the optimization process. For instance, Hart, Price, and Srebro proposed a method for achieving equalized odds, which ensures that the false positive and false negative rates are equal across different demographic groups. Practical tools such as fairness indicators and IBM AI Fairness 360 offer frameworks for assessing and mitigating bias in AI systems. Fairness indicators, developed by Google, provide a set of metrics and visualizations that help identify bias in machine learning models. These indicators can be integrated into existing workflows, allowing practitioners to monitor bias throughout the model development lifecycle. Similarly, IBM AI Fairness 360 is an open-source toolkit that provides algorithms and metrics for measuring and reducing bias. It includes pre-processing, in-processing, and post-processing techniques, enabling users to address bias at different stages of the model pipeline. By leveraging these tools, professionals can gain actionable insights into the fairness of their AI systems and implement corrective measures as needed. In addition to technical solutions, reducing bias in AI requires a broader organizational commitment to ethical AI practices. This involves fostering a culture of accountability and transparency in AI development. One effective strategy is to implement ethical guidelines and frameworks that outline the principles and values guiding AI projects. The Partnership on AI, for example, has established a set of guidelines emphasizing fairness, transparency, and accountability in AI systems. Organizations can adapt these guidelines to their specific contexts, ensuring that ethical considerations are embedded in every stage of AI development. Moreover, engaging diverse teams in the AI development process can help mitigate bias by bringing varied perspectives and experiences into the decision-making process. Research by Page indicates that diverse teams are more effective at problem-solving and innovation as they are able to approach challenges from multiple angles. By involving individuals from different backgrounds, organizations can identify potential biases early on and develop more inclusive AI systems. This approach not only enhances the fairness of AI models, but also promotes trust and acceptance among users. Case studies provide valuable insights into the practical application of these methods and tools. For instance, the COMPAS algorithm, used for recidivism prediction in the criminal justice system, faced criticism for its biased predictions against African American defendants. An analysis by Angwin et al. Revealed disparities in the false positive rates between different racial groups. In response, efforts were made to develop fairer algorithms that ensure equitable treatment across demographic lines. These case studies underscore the importance of continuously evaluating and improving AI systems to align with ethical standards. Statistics further illustrate the impact of bias reduction efforts. A report by McKinsey & Company found that organizations that prioritize diversity and inclusion in their AI initiatives are more likely to outperform their peers in terms of innovation and financial performance. Additionally, a survey conducted by Deloitte revealed that 90% of AI leaders recognize the need to address bias in AI systems, highlighting the growing awareness and commitment to ethical AI practices. In conclusion, reducing bias in AI is an essential step toward ensuring fairness and equity in AI-driven decision-making processes. By understanding the sources of bias, implementing practical tools and frameworks, and fostering a culture of accountability and transparency, professionals can effectively mitigate bias and enhance the fairness of AI systems. Data augmentation, fairness-aware algorithms, and open-source toolkits provide actionable insights and strategies for addressing real-world challenges. Furthermore, engaging diverse teams and adhering to ethical guidelines can promote inclusivity and trust in AI systems. Through continuous evaluation and improvement, organizations can create AI systems that align with ethical standards and deliver positive societal outcomes.